Hello everyone, I'm going to take you through my exam paper for AI, and my AI project is solving ill fit. So my presentation is going to have the introduction, the background and motivation, literature review, methodology, supervised and unsupervised learning, exploratory data analysis, splitting data, fitting the model, and then evaluation of the model. Problem is ill fit among outfits ordered online. Many people are ordering clothes online, and it's frustrating to order clothes and doesn't fit you perfectly. Fashion designer also feels nagged during doing the same piece again, and may cost them about 35% of that total cost to refine the outfit. However, with this project in place, the customer size will be predicted if they input the weight, age, and height. This will reduce on the rejected orders by customers and will also create a goodwill for the online platform implementing this. The keywords are ill fit, fashion, body measurement, and artificial intelligence. Being a fashion lover and a fashion designer, major problem I've faced is getting the perfect size of a client. The keyword body size means the size of the client that will be used to measure the dimensions for the outfit. This will come as an output after the client has input their weight, height, and age. This relates to fashion as in the fashion industry, and I shall be using artificial intelligence to get a body size. Ill-fit is when an outfit does not fit the client perfectly. It may be oversized or undersized. This is the major problem I'm trying to solve, and it will not only benefit the fashion designer, but the clients as well. The literature review, the review questions, such questions are: what are my target classes, their decisions and options? How interpretable is our machine learning model? How data was collected or what is being used and how it's available? How data is processed? How we train and test our model? How evaluate our model? Accuracy of the model based on the set target and problems being solved. How satisfactory we shall be when a model is a success. The review the research objectives to acquire the appropriate and available data set to be used in the project, to be able to manipulate and process the data effectively, to achieve the required results with high accuracy, to get the best machine learning model that is easily interpretable and can work well with the available data sets. I intend to use Decision Tree Classifier to get the size of my clients given their weight, age, and height. To fully satisfy our target groups by addressing the problems at hand. For this case, having a customer get an outfit that fits them well and also maintaining the goodwill of the online platforms and fashion designers. Methodology, I'll have the data set description. I consider the size of my data set, variety in the data set. Data set with variety helps reduce on biases. Availability of data set. The data set I chose is available for search and computation. Features my data set in order to select my data set. The data set I'm using have majorly 4 features, 2 of which are supposed to be input by the user, i.e. the weight, age, and height, and the other, the size, which is the output got based on the input. Supervised and unsupervised learning techniques. The supervised learning techniques include the k-nearest neighbor, where the unlabeled data set is arranged into clusters which must be of similar properties. It then assigns a new object to a class common among its k-nearest neighbors, and anomaly detection, where abnormal features or data points in the data set are detected. This can be detected in the outliers plots. The supervised learning technique include the linear regression and decision tree classifier. However, in my project, I'll be using the decision tree classifier to build my model. Exploratory data analysis. Exploratory data analysis helps one to critically understand the features in the data set, clean the data where necessary. This can be by removing duplicates, dropping or filling up the null values. For my case, I cleaned my dataset by replacing all the rows with mean value. This was for age and height. I also dropped all the duplicate values. Splitting data and fitting the model. Before splitting my dataset, I first grouped the features, the input, output, X, Y, respectively. The input was the weight, age, and height, and the output, extra small, small, medium, extra large as the size, which varies depending on the input. I split my dataset into three, the ratio of 14:3 for training, testing, and validating respectively. This was done for both the input values X and the output values Y. I use a decision tree classifier since not all my values were numerical. In other words, the input values were numerical, but the output values are not. The decision tree classifier model was fitted with X train and Y train values. Heat maps. Heat maps help us to know the relationship between various features in our dataset. I consider the input values, age, and height since they are numerical. The darker values show a higher correlation between the features, and the lighter shades show a low correlation between the features. Correlation matrix. Correlation matrices provide us with the values we can use to determine the precision, accuracy, F1 score, and recall. With its values, we are also able to see the relation between the features in our dataset. The values range from strong negative low correlation to strong positive high correlation. Box plots help us generalize and analyze the distribution of numerical values in the features. They help us to know the maximum, minimum, medium quartiles of our features. My box map is for 3 numerical features in my dataset, that is to say, the weight, age, and height. The outlier plots appear at the extreme ends and vary so much from the mean. This can be seen on this box plot. Patterns of interest. My patterns of interest were in weight and height variables, which had a relatively high correlation as compared to age and height and age and weight. I did not have any variation in time and space, as my data set did not have any factor depending on time and space. Evaluation metrics. Recall it said classification metrics used to measure the performance of a model. It's also described as a way of remembering or making insights based on the past. And this will also be based on customers' feedback. Accuracy. This is a ratio of correct predictions of all predictions made by an algorithm. F1 score. This is a way to measure how much accuracy is present in a data set. Precision. This is the value that gives us the value of numbers of times one took the correct action, of all times one took the action. Focuses on the true positive and false positives, therefore providing a representation that may be missed by accuracy. Evaluation of the model. After fitting the model, I used the X test as the input to get predictions which were later compared to the Y test values determine accuracy. The accuracy kept varying as we used the K for the cross-validation to split the data, for training and testing. The ratio of 8 to 2 respectively. However, the range of the values was between 0.523 and 0.621. Thanks for listening. This is the end of my project. Thank you.